Most students walking to class have no idea there's a massive heat rejection engine humming right over their heads. When the AC is blasting in a lecture hall, that heat doesn't just disappear. It's collected by the chilled water system and carried up here to the cooling tower. This is the final stop for all the heat generated by thousands of people, computers, and lights inside the building. Here's how the handoff works. Inside the basement, a chiller is working hard to cool the building's water loop. But as it chills that water, it gets hot itself. We use a separate condenser water loop to carry that heat away. This loop pumps it straight to the roof. If it stops moving, the chiller trips on high pressure, and the whole campus loses AC in minutes. Once that hot water hits the tower, it's sprayed through these nozzles over the fill. Think of the fill as a massive radiator with a huge surface area. We want that water to move as slowly and thinly as possible. As the cooling tower fan pulls air across the thin film of water, a tiny amount of it evaporates. That evaporation is what actually steals the heat from the rest of the water. This is the most efficient way we have to move massive amounts of energy out of a building. But here's where it gets real. Because this is an open system, it's a magnet for trouble. Dust, pollen, and minerals from the city water supply stay behind when the water evaporates. This leads to scale buildup and algae. If you let that scale coat the fill or the chiller tubes, your efficiency tanks. That's why we're out here on a Saturday checking the chemical feed and bleed. No water treatment means no cooling. Managing a campus cooling loop isn't just about turning a wrench. It's about mastering water chemistry and thermodynamics to keep the environment stable. If you're one of the techs keeping the hidden side of the world running, stay tuned to Mate Logic. We're diving deep into the machines that matter. Like, subscribe, and stay cool. I'll see you on the next shift.